Bana ba bangata ba hola ba ntse ba utlwana le thuto ya dipalo o fumane hore ha ntse a nyoloha bo grade 1 o fikela grade 7 ka nnete ntho tsa hae di ntse di le hantle di dutse thekeng la tshwene fela ha fihla high school kwana sa etsa bo solve for x sa etsa bo di geometry monana ho be le fifi bana ho be le fifi bona hape hore motho jwale ka tsela ya sa le ka teng o se bile a inehetse ka jeno ke tlo leka hore ke demystify mathematics and try and get your child to be on the right track with mathematics. In this video, we are going to do the Solve for X Bootcamp. What that means is that we are going to do all the possible ways that Solve for X can appear in the curriculum in grade 8 and grade 9 and how to go about it.
Lebitso la ka ke nyakallo.lephoto thuso wa bana setseng sa thuto sa thusa bana community center se fumanehang motseng wa Katlehong Pfapfa re thusa bana ba ntseng ba haella sekolong from grade 1 ho fihlela ho grade 7 mantaha ho fihlela Moqebelo ho ba hoshana le motse wa Katlehong re na le di-online classes mantaha ho fihlela Labohlano.
Let us commence with Solve for X, which is essentially one of the most important, if not the most pivotal aspects of your high schooling journey when it comes to mathematics, particularly with regard to algebra. We are going to do this lesson in 4 parts. The 4 parts we are going to do the Solve for X, as it pertains to integers, the subtopics there, we have the transpose and divide, all of those things. I will explain that as and when we go. Then as we scroll down the list, I'll be deleting the ones that we have already done, just as to show you where you are at this particular juncture. Basically, this is how our itinerary is going to work. The first one, as you can see there, is transpose. So we are going to show you now what you need to do when you have a simple solve for X problem that needs you to just transpose. A lot of them will come up in a form such as the one you see on the board. We'll have x minus 1 equals to 5. So what this will essentially require is for you to take up this -1 and transfer it onto the other side, in which case it will change the sign and become +1. That's all there is to it, because what we want is that on the left-hand side, we just need to have the unknown, and on the right-hand side, we need to have the constant. That's what Solve for X essentially is all about. Now, let's move on to the next step. I'll do it in blue ink, where I'll show you how that the -1 has moved from the left-hand side onto the right-hand side. Essentially, we had x minus 1, rather. Now we are going to add +1 so that it cancels that. It's the opposite thereof. Then it gives us a 0, and then we have a 5, which we already had on the right-hand side. But what we did on the left-hand side, we also have to do on the right-hand side, so as to obey mathematical laws. This yields, or rather this has achieved to get rid of the -1 on the left-hand side, but it has also introduced the +1 on the right-hand side. Mathematically, that is sound. On the left-hand side, we are now left with x is equal to 6. The simplest form of solve for X. Basically, what you are doing is you're taking the constant on the left-hand side and you're moving it onto the right-hand side. We call that transposition, because here at Tusabana, we believe firmly in repetition. I'm going to do one similar to that, and every topic that we are going to cover here, I'm going to do at least 2 examples so as to actually make you understand how that goes. We're going to do a big-ish number here, which is not common, however, it will come. And also, it just shows you that it is something that's allowed. X plus 40 is equal to 5. As you can tell, we are going to take the constant on our left-hand side. We take it together with its sign and we transpose it onto the right-hand side, in which case when it arrives, it's going to now have a different sign, which is a negative, and yeah, that will be our negative 40 like that. Let me use blue ink again just to demonstrate how this came about. We had x plus 40, but for us to get rid of the 40 on the negative side, we have to introduce the opposite thereof, which will cancel it out. In this case, it's a negative 40. But the golden rule of mathematics is what we do on the left-hand side of the equation, we also do on the right-hand side of the equation, so as to keep parity and keep everything mathematically balanced. What this yields is that the 40 now gets cancelled by the negative 40. But we have now introduced, if I can find my cursor, we have now introduced the negative 40 onto the right-hand side, which is okay. Mathematically, Albert Einstein will agree with this, and then we have x is equal to negative 35. This is the simplest form of transposition. We have covered that, and let's move on to our itinerary, where we can move on to the next steps. We are just scratching off the transpose, and now we are moving to transpose and divide. What does transpose and divide do, and what do we need it for? We need the transpose and divide when we have a coefficient, a coefficient of x, so that not only are we searching for, we are looking for solve for x and not for solve for 3x or whatever has accompanied x in that particular case. I hate it when the board is just blank like that. What I mean by that is this. Let's take a question such as 3x plus 4 equals to 10. So you can see how that works out. We have 3x plus 4 equals to 10. You can see this is not just an x, but an x now has a friend in a form of 3. Now, the first operation we are going to perform here is to take this 4 and transpose it onto the right-hand side, as we did in the topic above, which will yield, because the 4 was positive rather, it now becomes negative when it enters the right-hand side. We are now going to be left on the left-hand side with, or maybe I should show you the blue ink steps, which will fall off later on and when we become comfortable with that. 3x plus 4. Now, what we want to do is to get rid of this 4, so we're going to have to introduce the negative 4, which is essentially the opposite thereof, which gets rid of it. But what we do on the left-hand side, we also do on the right-hand side. Then we're going to have 10 minus 4 on the right-hand side. Essentially, this is how it's going to happen. It will yield this result, getting rid of the 4, but it will also have an perhaps unintended consequence of introducing the negative 4 on the right-hand side. We now have 3x on the left-hand side equal to 6. something we haven't seen up until this point. Going back to blue ink, we are going to have this 3x. We're going to divide it by 3. Isn't it? When we were transposing, we were subtracting or adding 3, but in this case, we are dividing. But what we do on the left-hand side, we also do on the right-hand side. Then we divide by 3 on this side as well. What this will essentially achieve is that the 3 will cancel the 3, and then we'll be left with x is equal to 2. That
ke re ke seditse kgatiso ena na go tsebisa ka monyetla o teng wa gore o ka fumana one-on-one consultation le nna ke o thuse jwalo ka ha ke thusa ka di-online classes go tloga go bana ba grade 1 go fitlhela go bana ba grade 12 ke specialize ka English, Sesotho ga mmogo le mathematics. E ka ba o hloka thuso ka bo fonetiki, maele, di-solve for x, taba tsa mofuta o jwalo, ke kgona ho thusa le wena a ntseng a ithuta ho ba titjhere go tloha first year ho fihla fourth year, foundation phase ho fihla senior and FET. Ke a kgona hore ke o thuse ka yona tsela enana ya online. It's a 40-minute consultation, then re ka ba le follow up ha e le hore ho na le moo sa utlwisisang teng. The initial consultation ke 150 ranta fela, then follow up ke 100 ranta. Hangata ke be lesson tse pedi le baithuti ba ka e le gore lesson ya pele ke 150, then ya bobedi ke 100 ranta, 250 ranta for those 2 lessons mo e leng gore o thusa ka bo assignment ya hao, ke be ke o thuse le ka tse ding tse ngata. Ke a tseba baithuti ba na le these modules tse re bitsang ka gore ke di-generic modules mo e leng gore moithuti o tla ba ipotsa gore jwale di-teaching lesson tse di tsamaya jwang, di-learner methods di fapana kae ho di-teacher-centered method, di-theorist tsena bo John Dewey, bo Bangura, bo Piaget, ke tabanyana tse ngatanyana tse leng gore baithuti ba sokola ka tsona, bo Bloom's taxonomy, bo scaffolding, taba tsa mofuta o ke kgona gore ke o thuse. 078 383 3396 ka tsela ya SMS, voice note, or pick up the phone, call in and say Shafere who's a Linyora, le ka tsela ya email ke a fumaneha nyakallo.lephoto @gmail.com. ke a pheta hape nyakallo.lephoto @gmail.com.
is that with that, now repetition. Repetition here to Savannah, we believe firmly in repetition. You can't just do it once and believe that you know it all. The learners have understood it. We need to do another one similar to it. We now have 4x minus 10, which is equal to 6. The first step, as per tradition, we are going to transpose this negative 10. I like the heart shape there. And when it gets to the right-hand side, it becomes positive. So we now have a positive 10 in this fashion. Now, how we have achieved this is we have 4x, but because we need to get rid of the negative 4 or the negative 10 first, before we do anything else, we have to introduce the polar opposite thereof, which is positive 10, which will give us a 0. Then on the left-hand side, on the right-hand side, we will do what will give us this unintended consequences that we really do not mind of introducing a 10 onto the right-hand side. Then we have 4x on the left-hand side. And on the right-hand side, we have 16. Flies even in winter. Yeah, it's crazy, man. Then we are going to have a blue ink step. You must pay attention to these blue ink steps because as we proceed with the lesson, they're going to disappear. They're going to be like one of those things we just assume you know how we achieved what we did. But for a lot of people starting their journey in high school mathematics, it can be a little daunting. And when things just disappear, they're like, how did that happen? So we need to show them step by step as to how that actually transpired. We now have 4x divided by 4, which has yielded the 4's cancelling one another. However, what we do on the left hand side, we also do on the right hand side. X now is equal to 4. We do know that there are 4 4's in 16. Let us move on to the next operation with regard to integers. If I could just change the view back to the itinerary and scratch off the transpose and divide and move on to what we term the double transpose. The double transpose, what it does is that we are going to, isn't it up until this point we were just moving constant from the left hand side onto the right hand side, but what we are going to now start doing is to move in both directions. So we're going to be moving the constants on the left hand side, but we'll have equations that have unknowns on the right hand side, so we need to move those unknowns onto the left hand side. An equation such as this one, 6x minus 6. So when we have 6x minus 6 equals to, now we have 9 plus x. Up until this point, we hadn't met an equation that has both the constant on the left hand side and on the right hand side. So what we need to do is to take this negative 6 here and move it onto the right hand side, in which case we know that it will become positive 6. But not only do we need to do that, we need to take this positive x and move it onto the left-hand side, where we know that it will change the sign and become a negative. So it's a double transposition in that case. I don't know if it's a formal term, but that's the one I prefer to use for these lessons. Now we have 6x for the blue ink step minus x that we got from that right hand side. But for us to get rid of the negative 6 here, we have had to introduce the positive 6, which will appear on the right hand side. And this is how it is. And then we have the equal sign here. Then the 9, we keep it here because we want the constant on our right hand side. We have the positive x here, which we will get rid of by introducing the negative x. Then x will be minus x, which gives us the 0. And then that positive 6 that we have taken from the that we have introduced on the left hand side, we also now introduce on the right hand side. What this achieves is that we have negative 6 plus 6 cancel out, become a 0, and then we have the x minus x as well, they become 0. So the resultant step is such that we have, in black ink, 6x minus x equals to 9 plus 6. This gives us 5x is equal to 15. For the blue inkers, we are going to divide, and then we have 5x equals to 5. No, divided by 5. So because we want to get rid of that 5. But what we do on the left-hand side, we also do on the right-hand side. It will appear in this shape, form, and manner. What this is essentially achieved is that the 5 is cancelled the 5. We are left with x, but we know that there are 3 5s in 15. This is what it is. Repetition. We're going to do another step similar to this. This is why the video gets a bit long, but it helps in that you get 2 opportunities to actually see. Hey man, and that's exactly what you need in your schooling career. 4x. Especially with regard to mathematics, man, practice. Man, you need to do more than you actually are required to do, especially for those that want to do more than what the class or the grade average is going to be, which will get in an opportunity to get bursaries, things such as that. The extra mile is the name of the game. We have 4x minus 21 equals to 5 minus, believe it or not, this is an x. I'll tell you the story why I'm working with the mouse right now. I bought the pen device, but what it does is it slows down the videos. I don't know how many times I've tried to work with it, and it hasn't essentially worked out for me. But it works for the online classes, but not for this particular app or program, which is okay. Now we are going to move the negative 21, move it onto the left-hand side, right-hand side, and it gives us 21. Positive 21 as it were. Double transposition, as we said, so we're going to take the negative. You need to take even the sign, which is what a lot of people fail to do. They just take the 9 and then they make it positive on the side. Or they make it negative on the side. It needs to be positive because it was negative on the right hand side. Work with a lot of learners. Like, I'm like, 9x I'm like, it's not 9x, it's negative 9x. So blue ink, we are then going to have 4x plus 9x on the left hand side equals, we have 5 plus 21. So what we have on the left hand side is 9 plus 3 gives us 13. 9 plus 4 gives us 13. Is that what I said? Should be what I said. And then on the right hand side, we have 21 plus 5, which gives us 26. One of the best crafted questions that I have helped to work with in my mathematical career, because we are going to divide by 13. So the blue ink as well. Pay attention to these blue ink steps because they are going to disappear in the later stages. So that's going to be 13, divide by 13. And on the right hand side, we have 26 divides by 13. What this yields is then the 13 cancels. The 13, we have x. Don't know if it's visible there at the bottom. We know that there are 2 13s in 26. Let's move on. Let us move on and now see, in a situation where x is negative, I'm going to do just one was that a problem of this nature. Up until this point, we were doing problems that give us x in a positive format. What happens when we have x in a negative format? We are going to do a double transposition problem. 3x minus 6 equals to 5x minus 4. We are demonstrating what happens when x winds up negative. Similarly, as we have been doing throughout the course of this lesson, we've been taking the constant to the right hand side, and we've been taking the, maybe I can do this in an upside down manner. Let me see. Yeah, here we are. How do you like that? We've been taking the unknowns onto the left hand side. What this achieves is we are going to have 3x minus 5x equals to negative 4 plus 6. All right, so that's a positive. Now we have negative 2x in this case. On the left hand side and on the right hand side, we have just a positive 2. Now remember, what we are trying to achieve here is a situation where this negative disappears. Okay, let me highlight it. This negative disappears. But as we have been doing in the past, what we have been doing is we will have, let's say, negative 2x, and we would divide it by 2. But in this case, we are going to divide it by the negative as well. What that will achieve is that it will cancel not only the 2, but it will cancel also the negative sign. It will just bring it to the right hand side, leaving us with the situation where we no longer have a negative on the left hand side. This will happen. This negative will cancel this negative. This 2 will cancel. This 2 will be left with x on the left hand side, which is an ideal situation. And on the right hand side, we don't mind negative signs on the right hand side, as we have here 2 into 2, we have 1. That's that with that. Now we are moving on in our itinerary. The next item on the itinerary will definitely be the distributive property of multiplication. We did this in primary. We are doing this in high school now in a form of maybe slightly more complicated questions and problems, but the properties still stay the same. Let's move right along because we have so much to cover, and also we are doing two problems per item, so that does take us a bit of a while. But like I said, repetition, you know what it does. X into 2 into x minus 2 equals to 10. Let me do this. This looks like a 7. Let me just let it be curvy, like it's a bracket. All right. Into is equal to 10. The distributive property is such that 2 multiplied by, let me see what you are seeing on your screen. 2 multiplied by x and then 2 multiplied by -2. That's what the distributive property will achieve. So we're going to have 2x minus 4 equals to 10. Now, as it is, this problem presents us with something familiar, something that we have been doing all along. We are then going to take this constant and move it right onto the right-hand side where it will become a positive 4, and everything else will be left on the left-hand side, which will achieve a situation such as this one. 2x is equal to 14. Now, we are not going to do the blue step at this particular juncture because you guys are grown boys and girls. You do know that when you divide by 2 on the left-hand side, you just left with the x, and when you divide by 2 on the right-hand side, 14 divided by 2 gives you 7. Act like you know. Need to put this on flight mode just in case somebody wants to call me. All right, let's move on to a second example of something similar to this. Maybe we should have 2 brackets, the one on the left hand side of the equation and the other one on the right hand side, which will essentially be a longer problem, but the principles remain the same. When you know the rules of mathematics, it doesn't really matter what the problem is, what problems you're facing, how complicated it is. All you need to do is to just apply the rule. 4 into x plus 3 equals 5 into 6x minus 2. And then outside of the bracket, we have a solitary 3. Remember it. All right. Simple distributive property. We are going to have 4 multiplying by x and then 4 multiplying by that positive 3. And then on the right-hand side, we're going to have 5 multiplied by 6x and then 5 again multiplied by the -2. The solitary 3, we just leave her as she is. What this achieves is 4x plus 12. And on the right-hand side, we are going to have 5 by 6 gives us 30x minus 10 plus mahamba yethu. So we are going to then transpose. We're going to take this 12 from the left-hand side onto the, wherever you can put the 12, where it will become negative rather. Negative 12. And then we are going to take this 30x and transfer it this side where it will become negative 30x. All right, it's a little messy, but I just needed to demonstrate that. Let's take a positive. So we're going to have 4x minus 30x is equal to negative 10 in this case, negative 12 plus mahamba yethu. On the left-hand side, we are going to have negative 26x And on the right-hand side, we are going to have negative 22, positive 3. It gives us negative 19. So on the left-hand side, we are going to have x is equal to, the negatives will cancel out one another. So we're just going to have 19 over 26, which I am 99.9% certain that you can't simplify any further than that. Let us move on to the next item on our itinerary. We're scrolling down. We are winning at this particular juncture because we are moving to the part B of our lessons, and we are going to do fractions. The first item on the fractions list is going to be x as a denominator. What is a denominator? I think we also learned this in primary, and now in high school we have to do slightly more complicated problems just to show what we have learned, because we are now big boys and big girls. Now, x as a numerator. Did I say denominator? It should be a numerator, the first one that we are doing. So it works out like it is. So that's x over 2 is equal to negative 5. Let me first start off by explaining what a numerator is. Not that I need to, but a numerator is because there are two parts in your fraction. The one at the top is called a numerator. The one at the bottom is called the denominator. So for the next two problems, we're going to deal with the situation where x is at the top of the fraction. That's all there is. However, another thing I need to explain to you is if you have a situation where you are dealing with fractions with regard to solve for x, you just need to multiply by the denominator, which is the bottom part. Now, if x is your numerator, you need to multiply by the denominator so that everything falls off flat on its tummy at this particular juncture. So we are going to multiply by 2 so that we no longer have a omunye pesgo munye. We don't have a situation where there's a house on top of a house. We want everything to lay flat. How does that happen? Particularly in this, let me just use the blue ink just to show you what I mean by multiplying every term by the denominator. If I can find my cursor. So our denominator is 2. So we're going to say 2 over 1 multiply by x over 2. But as we have learned earlier, what you do on the left-hand side, you also do on the right-hand side. What this achieves is that we're going to have 5 multiply by 2, rather negative 5 multiply by 2. On the left-hand side, this 2 will cancel this 2. We're just going to be left with the x. Exactly what we want to happen. Everything to fall flat on its tummy. We don't want things on top of one another. But on the right-hand side, negative 5 multiplied by 2 gives us negative 10. And that is that with that. Simplest thing you could ever do by just multiplying by the denominator. Let's move right along onto the next question, which deals with x as a numerator. And our secret weapon in a situation like that is to multiply by the denominator. Whatever the denominator is, that's what you're going to multiply by. We have 2x over 5 plus the solitary 3 constant. I'm going to show you how we work with that one when you have a constant, and on the right-hand side, we have 11. Now, I would like to start with transposing this and put it out onto the other side. I know there are people who just start off by multiplying every time. I feel like it takes so long to actually get to the solution. But if you do it this way, then you are all good. Let's do it in blue ink and see how that, but no, before we get to the blue ink, let's just, okay, this one will be a negative 3. Just in case we forget. And then we are left with 2x on the left-hand side over 5 And on the right-hand side, we have an 8. Now, like what we did earlier on, you are going to multiply by this, the denominator. What this yield is 5 over 1 multiplied by 2x over 5 will give us 8 multiplied by 5. Then we will have this 5 canceling this 5, and then we're going to be left with just the 2x. On the left-hand side, and on the right-hand side, because we multiply this by 5, on the right-hand side, we're going to have 40. If you divide those by 2, you are going to have x equal to 20. X equals to 20. Nothing difficult, and this is why we are moving on to the next item on the the itinerary, which is now what happens when the roles are reversed. The juxtaposition of this particular situation where we have see how easy this is to happen, where we have x as your denominator. So in other words, x is at the bottom of the fraction. One of the easiest things to do, quite frankly, because you are going to multiply by the denominator. So in this case, you're going to multiply by the x. When x was a numerator, you were multiplying by the constant at the, or whatever is at the denominator. Let's just put it that way. Let's not complicate it. So here we are, 6x, rather 6 over x is equal to 3. No, it's equal to -3. So it's very simple. You are just going to multiply by the negative. Can I see if I have an upside down hat? Beautiful. Simply beautiful. You're just going to multiply every term by the x, and this is how that's going to pan out. We're going to have a 6x, rather 6 over x multiply by x over 1. But what you do on the left-hand side, you also do on the right-hand side. We're going to have a -3 at this particular juncture, which we are going to multiply by the x, the 3 curves. Then what this will achieve is that the x will cancel this x. We are just going to be left with the 6 on the left-hand side, and on the right-hand side, we are going to have a -3x, which poses another situation we've never seen before. But you can just take this and move it onto the left-hand side so that it's something familiar. Equally, you can take this 6 and take it onto the right-hand side. Just exchanging them is perfectly legal, which is what we are going to do so that we have something that we are more familiar with. Familiarity breeds contempt. Not a bad thing in mathematics, quite frankly, but in real life, different story altogether. So we now have this 6, and now we are going to divide by -3, which gives us an x on the left-hand side to chop the -2 that we have on the right hand side. Act like you know, and that's how it works. When you have x as a denominator, you are just multiplying by that so that everything falls flat on its tummy, and that leaves us with a level playing field. That's what you want to do. Let's do the second one, where we still have x as a denominator, perhaps with more terms this time around. Let's have 5 over x. That's a 5 over x plus 3 no plus 4. 5 over x plus 4 equals to 3. Now the first thing we need to do is to transpose this positive 4 and to move it this side rather, where it will be a negative 4. What that leaves us with is 5 over x on the left hand side. And then on the right hand side, we just have a negative 1. And then we are going to multiply by the x, which will give us negative x, like you know, equals to 5. And then dividing by negative 1 will give us x equals to negative 1. And that's that. With that, we have now demonstrated what happens when x is a numerator and when x is a denominator. What we need to move on to is the next item on our itinerary, is when x-composite is a numerator. This is where we are. By x-composite being a numerator, if we could just quickly wipe the board, we mean when you have x accompanied by other things, and all of that is over something in this format. Gibberish, I know. 2x minus 3. Everything over 2. So this is what we mean by an x-composite. I don't know if it's a formal term. I just made it up for this particular video, but it could be close to the real thing, if not actually what appears on the formal maths textbooks. Then we have that minus 3x plus 1 over 4. Everything equals to 1. Now, remember from the previous questions, we would have multiplied by the denominator so that everything falls flat on its tummy. But now what happens when the numerators are not, the denominators are not the same? We are going to take the LCM. We're going to multiply by the LCM. The LCM of 2 and 4 is 4. Another thing we actually did in primary. What this will yield is, if we could just have it in blue ink, we are going to have, because the LCM is 4, we are going to have 4 over 1 multiply by 2x minus 3, everything over 2, and then minus 4 over 1 multiply by 3x. plus 1 over 4. And on the right hand side as well. So you're multiplying all the terms actually with so on the right hand side, we're just going to have 4 multiplied by 1. Let this not. So what this will yield is this 2 will cancel, will go into 4 twice. So you're going to have 2 into 2x minus 3, which presents something we've seen before, the distributive properties. And this 4 will cancel this 4. We will then have 3x plus 1 equals to 4. I feel like I missed something, didn't get something right, but yeah, that's fine. So the distributive property will give us this multiplied by this, and then this multiplied by this, resulting in a few extra steps, but why not? 4x minus 6 minus 3x plus 1 equals to 4. Just grouping the like terms. We are going to have x on the left hand side because 4 minus 3. And then on the right hand side, we are going to have negative 6 plus 1, so that's 5. If we make 5 skip onto the right hand side, it's going to be, because it's going to be negative on the side, on the right hand side it's going to be positive, so we're going to have 5 plus 4, which gives us 9. All right, let's do a second one, and yeah, just for demonstrative purposes, perhaps a more shorter one with fewer terms. Let's just do one with 2 terms. But that's that. With that, you need to multiply by the LCM when you have the denominators not the same. So we are going to have 4x plus 7 over 7 equal to 5 minus x. Everything over 2. Again, the denominators are not the same. Perhaps this should just be when the denominators are not the same as opposed to a composite. But basically the LCM of 2 and 7 is 14. So we are going to multiply both the terms by 14, which will yield something like this. So we're going to have 14 here over 1 multiplied by 4x plus 7 over 7 equals to 5 minus x over 2 multiplied by 14 over 1. I just want to check if everything is recording here. Yeah, microphone is on. So we are going to have a situation where 7 into 14 goes twice, takes us to the distributive property. So we're going to have 4x plus 7 equals to 2 into 7 gives us 7. 5 minus x. The distributive property gives us this. Two x multiplied by 4x plus 2x multiplied by 4x, and then we're going to have 2 multiplied by 4x, also 2 multiplied by 7, and then we are going to have 7 multiplied by 5, and we are also going to have 7 multiplied by x, which yields on the left hand side we are going to have 8x plus 14, and on the right hand side we are going to have 35 minus 7x, and then we are going to have to transpose. When this 7 gets onto the left hand side, it adds to the 8, which gives us 15x on the left hand side, and on the right hand side we have 14 is going to be negative when it gets to the right hand side, so that's 35 minus 14 should give us 21. So when we divide by 15, it will give us 21 over 15. 15, which gives us, simplifies to 7 over 5, because we can further divide by the 3's. And that's what it is with regard to the x-composite. But I think what this has also demonstrated is what you do when the denominators are not the same. I wasn't quite aware of that until I tried to go through this. Then I realized that that's what it actually yields. So now we're moving on to the next itinerary on our... Moving on to the next item on our itinerary, a bit of a mouthful, but what it essentially yields is, don't know why it's a blank screen. We are then going to move on to, I'm going to skip the x-composite as a denominator. It's going to be a bit of a long thing. Let's just move on to x as an exponent, and we are going to do x as an basically we're doing exponents. So for x with exponents, and the first one we are going to start with is x as an exponent, and then we'll do x as a base. It gets easier from here on in. We are effectively now on part C of our boot camp, and we are going to deal with exponents. So the first aspect of exponents we are going to deal with is when your when your x is an exponent, and then the second part will be when x is your base. Like I said, it does get a whole lot easier. So let's go when x is an exponent. First example is 3. We have here x minus 2. So in other words, That's 3 to the power of x minus 2 and everything equal to 81. When you're dealing with exponents and x as an exponent in this mold, because you already have a base, make sure that the constants are such that the base is equal to the base that you have on the other side. So in other words, you need to have 81 as 3 to the power of something, right? So that the 3, this 3 can cancel this 3 and you'll be left with just this, right? X minus 2 is equal to something. Then we can just solve that as per normal. Let me show you how that works out, because we already know that 81 is 3 to the power of 4. We are then going to say 3 x minus 2 is equal to, like I said, the bases have to be the same when you're looking for x as an exponent. So we're having 3 here, and then to the power of 4. What this will yield is such that these fall off. The bases fall off. When the bases fall off, we are then going to be left with a familiar equation. X minus 2 is equal to 4. So our equation now becomes the exponents now become our equation. And that's all there is to it. It's not going to be any difficult. So we've done this before. We're just going to transpose the -2 onto the right hand side, where it will become positive. Then we are going to have x is equal to 6. That's all there is to it. That's all there is to it. When you're dealing with x as an exponent, just make sure that the basis of all the constants are the same. The basis will cancel, and then you will have a new equation that works out a whole lot easier, maybe to the effect where you can work with it from that point in. Let's move on to the next one. We are going to have 2 to the power of x plus 1 equals to 16. So like I said, we need to get this 16 to be in a mold of 2 to the power of something. 2 to the power of something. So that this 2 can cancel this 2, and we will have a whole lot easier equation to deal with. What this works out to is, because we know 16 is 2 to the power of 4, x plus 1 is equal to 2 to the power of 4. Now, the 2's will cancel one another. This 2 will cancel this 2. Then we're going to have x plus 1 equals to 4. Similarly, as we did in the previous one and at the beginning of the lesson, we are going to transpose this one, which then becomes 1. And when it gets to the right hand side, which then gives us x equals to 3. No other way. No other way to do this. Let's move on to the next item on the itinerary. Let me just leave it like this so that we have something there. Just looks a bit spooky when it's all blank. The next item on the itinerary is when x is a base, which is actually the juxtaposition. what happens, it's a similar situation with the numerators and the denominators. The juxtaposition, it's the opposite of the other. In what sense? Now, in this case, we have x. So we have 3. No, let's start with this one. Let's go 2x squared. 2x squared equals to 32. Right, let's just start off by dividing. So, isn't it, we have 2x squared over 2. So that we just left with the x squared on the left hand side so that we can perform our magic. But on the right hand side, we have 32 now divided by 2 as well. This will cancel this. I don't know why I'm still doing these steps. Like this one, I'm just spoiling. You guys are old now, we got 16 in this case. So, like I said, when you have x as a base, you need to have the exponents the same. Right, so you need to have this. So in other words, you need to have your 16 in a way that it is something to the power of 2, so that this 2 cancels out this 2. But we know that 16 is equal to 4 to the power of 2. So we have like x squared in this fashion is equal to 4 to the power of 2. Then the exponents cancel. And we have, maybe not in red ink, and then we have x is equal to 4. I repeat, when x is your base, make sure that the exponents are the same so the exponents can cancel. When x is an exponent, make sure that the bases are the same so that the bases can cancel. There's no other way to actually show you this. Let's move on to the last one, which is we have 3x squared, 3x to the power of 5 in this particular case. It's going to get rid of the coefficient, and then we do the magic. So that's 96. So now we're going to divide by 3. That's going to give us x to the power of 5 equals to 32. Then we need to get this 32. Such that it is something to the power of 5. You just need to make the exponents the same so they can cancel. Now, how do we get 32 to become the something to the power of 5? We know that 32 is equal to, so this is x to the power of 5 here. Then we are going to have 2 to the power of 5. What that would yield is this 5. Would cancel this 5. And then x. X would be equal to 2. All right, so let us move on to the next item on the itinerary, which happens to be the next cut, which is rather factorization. So we're going to do a quadrinomial, difference of 2 squares, and then the common factor, like isolating the common factor. The quadrinomial, I hear a lot of people calling it a quadrinomial. I don't know. The Englishist in me refuses to call it there. So let's just call it the quadrinomial. I think it makes sense in that shape, form, and manner. Rapetela, we are concluding with the part D of our itinerary. Oh, it's a bit of a tongue twister, I'm telling you, which is factorization. We are going to start with quads, and the first one will be x squared minus 2x. We are going to do factorization in more detail. I'll release a video thereof, but in this case we're just going to assume a whole lot of stuff. But if you need a bit more clarity with regard to factorization, then we will get to that in some or other future. What this achieves is you need to take the constant, your constant, and check the factors of your constant such that they yield the middle term. So now let's check the factors of our constant, which is -3. What are the factors of -3? Could be -3 and 1. It could be -1 and 3. Now, which of these two, when you multiply them together, actually give you negative? No, not when you multiply them together. When you add them together, give you -2. It's this pair, because that's where -3 is. That's where the 3 is negative. So it's -3. So in other words, let me just demonstrate it here. If you say -3 plus 1 gives you -2. It gives you this -2. So that's how you know which factors of 3 you are of the constant you are going to use. Let's put this in practice. No, could be a bit, but it's not a very complicated concept with regard to factorization. No, I don't know. If this was a Sotho, would say Sotho was Tolok. That's just how it is, man. That's just how it is. So we're going to have x on both the sides, which will work to yield the x squared. But because we have chosen this, so we're going to have x minus 3 on this side, and then we're going to have the plus 1 on this side. So this will result in x minus 3 equals to 0. By transposing, we're just basically going to have x is equal to 3. It becomes positive when it crosses the border line. And on the right hand side, we're just going to have or R, depending on which primary school you went to. So then we are going to have x plus 1 equals to 0. And then x equals to -1. No other way of going about this. Let's move on to the second example in this mold, where we are going to just check the factors of the constant such that they give us a middle term. X squared plus x is equal to 12. We just need to bring the 12 onto the left-hand side so that we can have our equation. We know it becomes negative when it crosses the border. And then we have a 0 on the side. So we are going to have to check the factors of negative 12 in this case, such that they give us, maybe I pointed to the wrong, such that they give us a positive 1. Now let's look at the factors of 12. We'll have 12. We're actually looking for the factors of negative 12, a negative 1, and then we're going to have negative 12 and 1. We are going to have 6. And negative 1. We're going to have negative 6. And 1. Or we'll have 4 and negative 3. And we'll have negative 4 and 3. But looking at these, the one that makes more sense for us, if we're looking for a positive 1, is where 4 minus 3 gives us a positive 1. So we're going to take this set of factors and place them here. Place them here. So we're going to have x on the, that's some curvy x, bro. Like, yo, that's some curvy x. And so we are just going to have a positive 4 and a negative 3. Which will yield x plus 4. Equals to 0. Then we have x is equal to negative 4. You know what you do on the left hand side, it's also what you do on the right hand side. Or x minus 3 equals to 0, and then we have x is equal to 3. That's that. So let's move on to the next item on our itinerary, which is the difference of two squares. So the difference of two squares essentially is such that we don't have a middle term. So we don't have a middle term. If we could just wipe the board and do two problems that do not yield a middle term. Let's see how that works out. So basically, we are going to have a situation where the factors cancel out one. Now, the first one is x squared minus 9. Maybe I should just go more central. X squared minus 9 equals to 0. So which factors of 9 will cancel each other? So basically two numbers. One number where you multiply it by itself gives you a 9. We know that it is a 3 because the square root of 9 is 3. So we are going to have a situation where we are basically just going to have x plus 3 and x minus 3. Right, so that this cancels this out. That's why there is no middle term here. Let's That's why there's no middle term here. Right. So what this essentially achieves is x plus 3 is equal to 0, which then x gives us a -3, and then you have all x minus 3 gives us a 0. What's this doing here? All right, so then we have x is equal to 3. Yeah, but it's been a long day. It's been a long day. When you're isolating the factors, let's do that and then go home. We have a situation where 2x squared, for instance, which is essentially this middle out of sorts at this particular juncture. It's been a long day. 2x squared minus 6x is equal to 0. So in this case, we are going to look for the factors of 2x, which are also the factors of, 2x squared, which are also the factors of 6x. So we have 2 in 2, but there's also a 2 in 6. So we are isolating that. But we also have an x in x squared, which we also have an x in x. We are going to isolate that. So we have 2x, which essentially gives us, when we take out 2x from 2x squared, we are just left with an x. Just dividing, basically, that's that. And then when we take out 2x from 6x, we are just left with 3. What this essentially gives us is something like this. Now we are going to have 2x is equal to 0, which gives x equal to 0. So that's the first possibility. The second possibility, a little possibility isn't an option. Then x minus 3. No. Equals to 0, and then we are going to have x is equal to 3, positive 3. When it transposes, it becomes a 3. Let's do the last one and then go home. School is out. Hey, man, 8x squared. 8x squared, the line it's all park. You know, it is 8x squared plus 4x gives us a 0, which then we have to isolate. So the common factor of 8 and 4 is 4. That's what we are going to isolate. The common factor of x squared and x, as we've done in the previous question, is going to be x. So we are going to isolate 4x into 8 divided by 2 gives us 2x plus 1. 4x divided by 4x gives us 1. Then we have a 0 this side. Then we're going to have 4x equals to 0, which will yield a 0. So x is equal to 0. Hey, I nearly wrote to 4. I'm tired. I'm really tired. So now this side we're going to write 2x, my 2x plus 1 rather, equals to 0. Then x is equal to, which we're still going to have 2x is equal to -1, and then x will be equal to -half. All right, so that is that with that. Thank you so much for tuning in.
Di hakana tseo re ne re tshwanetse tsona tsatsing la kajeno re le thusa bana community center e fumanehang motseng wa Katlehong Qwaqwa, re thusa baithuti ho tloha ho grade 1 ho fihlela ho grade 7 ka tsela ya contact ha o le haufinyana hoba hole re na le online classes Mantaha ho fihlela Labohlano. Nna ka lebitso ke nyakallo.lephoto, ka mehla le matsatsi ke re emela thuto ya ngwana hao ka maoto. Ke a leboha.